So thank you, Richard. I guess just to fill in some gaps there, because I've got colleagues from different parts of the university, and I never followed a traditional path. So I started life as an engineer, as an aeronautical engineer, and I did that for about 10 years. And then I became a physicist. So I did a master's in computational physics, and then I started to get involved in information technology, and that led me into the supply chain and ultimately into logistics. And that's interesting because the centre that I am involved in now, almost every aspect of my past occurs in that centre. So we do vehicle engineering, where we look at aerodynamics. We do lightweighting, where we look at carbon fibre materials, which I was involved with the very early stages of implementing aircraft structures with carbon fibre composites. We look at alternative fuels and computer modelling, and that's my computational physics. And of course, we look at supply chain and logistics. So today's event, I guess we could call it, is really about taking you on a journey through a little bit about the history of logistics and why that's important in the current form, and then to start peering into the future about how it's going to change. So it may not surprise you that I am not going to stand here for 30, 40 minutes and reinvent the wheel. I mean, when all's said and done, that's an elegant engineering solution to a very old problem. What I refer to really is the phrase trying not to reinvent the wheel. Okay? And that really refers to situations where we prefer to build on the endeavours of others rather than repeat the work ourselves. And that works most of the time, right? You know, most of the time we can just improve a little bit and things get better. But sometimes that isn't enough. And I'm going to sort of move into that space later on in the lecture. But I'd like to start with a bit of a story. Okay? The story, whether it's absolutely true or not, it makes a point. Okay? And the story refers to the space shuttle. And during the design phase of the space shuttle, there was a big discussion about how much energy it needed to get it out of low Earth orbit, or into low Earth orbit. And to get that energy on board the aircraft, the engineers said we need to make the rocket boosters bigger. Okay? Now that doesn't seem like a big problem. Okay? But in that meeting, somebody said, well, okay, that's a neat idea, let's make them wider. And then somebody said, well, you can't make them wider. But why can't you make them wider? Well, because where they are made, we have to transport them, logistics, from the factory through a tunnel by rail. Okay? So why is that such a big problem? Well, the tunnel isn't wide enough. It's not wide enough because the gauge of the railway is only 4 foot something and so many inches. Okay? So, and then the exploration of why that happened starts. And so the tunnel was that wide because the English, or the British, if you prefer, invented the steam engine. So they built it to certain dimensions. The steam engine was built on the same gauge as the horse-drawn carriages because of the ruts in the road and the manufacturing process was already in place. That was built based on the width of the horse and carriage. The horse and carriage was based on a Roman chariot. Has anybody got to the end of this story yet? Okay, well, it goes on for a bit longer. And the horse and carriage was based on the dimensions of the average horse's bottom. Okay, so you can trace a direct line in logistical terms from the size of a horse's bottom through to the space shuttle. Okay, and that tells us two really important things. The first is that our inherited past determines the possible pathways in the future. So where we start from determines where we can go to. The second thing it demonstrates is something that some people in the room already know, is that logistics is a really important economic activity. It's the means by which we get stuff, either raw materials or finished products, to the consumer. So, there's always been this relationship between, I can't see, oh yes, I've got to switch it on, that's why. This lecture's about technology and I forgot the on switch. Anyway, there's always been a relationship between GDP and logistics activity. And right up until about here, which is the sort of the turn of the century, that relationship followed. So the richer you got, the more logistics activity you did. The more logistics activity you did, the richer the country got. Okay? And then here in the UK, and this is potentially specific to the UK, it decouples. Okay? This is the point at which we became much more orientated to financial services as an economy. Okay? With financial services, you don't need to move stuff around, but you can create wealth. Well, you do need to move stuff around, it's data though. Okay? The next thing you observe is here, where things turn south, and that was the financial crisis. Okay? And here you can see that it starts to recouple. So just after 2010, this slope is steeper than this slope, and ultimately we expect them to join up again. And that's because the financial services sector isn't as important as it was in the previous 10 years. So there's always been a relationship between logistics and GDP. Now, there's also always been a relationship between logistics and the environment. And these graphics show you two things. The panel here is going to show you how concentrations of CO2 change between 2002 and 2016. This panel is going to show you how the temperature changes. It's on a different timeline because we have more records, and that's from 1884 to 2018. Okay, and I'll just play it. Right, now they're both moving, and I'm going to accelerate in time on the CO2. So now we are in 2010, and the redder it gets, the more CO2 there is, and the redder it gets on this other panel, the hotter it gets. So now we're in 2013. See, it's starting to get, changing colour quite a bit. Concentration of CO2 is increasing. If I move the temperature up to the turn of the century, so can't read it at the back, this is now 2003. 2016, concentration of CO2 has all gone red, and here, 2018, you see the temperature change. The main message of that is not the actual numbers involved. The main message is the rate of change. Okay? So the rate of change is very, very significant. And where does all this bad stuff come from? Well, most of it is coming from transport and energy generation. Okay, that's where most of the CO2 is coming from. We're obviously going to talk about transport, and in particular, I'm going to sort of talk about road freight. That's kind of my area of interest. So we ran, well, I say we, an organisation called ETI built a model, which is a computer model, which is known as ESME, which is the Energy Supply Modelling Environment. And they built a model that was designed to address how we could achieve certain carbon reduction commitments. Okay? Now, you may or may not know, I know some people in the room do because they work with me and they have been more heavily involved potentially in this sort of analysis. So the carbon reduction commitment in the UK is that we will reduce our CO2 emissions by 80% by 2050. Now that's overall CO2. Okay? From whatever source, we just need to have 80% of it, 80% less of it. Now, that's important because that's the figure we need to work towards if we were to avoid irreversible climate change. Okay? So those graphics that I showed before about temperature change, we're trying to avoid temperature increases of more than 1.5 degrees C now. We're not on course to achieve that, by the way. It's sort of going a bit the wrong way. But what this graph shows you is that if you assume we have to reduce emissions by 80%, then this model, the ESME model, looks at the lowest cost way of achieving it. Okay? First of all, it obviously tests whether you can actually do it, and then it looks at the lowest cost way of doing it. So, what this tells you is that, first of all, it is possible. Okay, this is a feasible solution. The second thing it tells you is that aviation and shipping, which is these blocks, don't change very much. And the reason they don't change very much is that to change those, you have to invest a lot of money for very little return at the moment with the technologies that are available. Okay? It also tells you that the transport sector, which is basically land-based transport, also doesn't change that much until we get into sort of close to 2050. It tells you that the power sector, the energy generation sector, decarbonises a lot. Yeah? So that's investment in renewables, and in this model output, an assumption that we invest in nuclear power. Okay? Even that doesn't get you to 80% reduction. The only way you get to 80% reduction is by building carbon capture and storage systems, stuff that takes out CO2 from the atmosphere. Now, the bad news in this story, and it's why the focus is starting to land on transport, is that we haven't built the nuclear power stations. You may have read in the press recently that the people who were going to build them have backed out of them. The second thing it should tell you is you may not have heard of any large-scale carbon capture and storage systems. Okay? Now there is a time sequence here, so these things have to start happening on this timeline. And you see, critically, carbon capture and storage is supposed to be in place around 2020, and that the decarbonisation of the energy generation starts to accelerate post-2020. Okay? Neither of those things are going to happen. That's the reality of the situation we're in. So, The thing that you can play with, the next best thing, if you can't fix the power generation and you can't do carbon capture and storage, is transport. Okay? So if you can generate enough decarbonised energy and get it into the transport sector, you then have a chance of achieving your 80%. And that's why I would argue that post-2020, which is a year's time, the focus of decarbonising activity in the UK will start to focus in on transport. Okay? Electric cars, electric vehicles, full stop, including freight vehicles. Okay? Technology is sort of catching up. I know there's some people here from the sector. Okay? So this is a Tesla truck which is being sold, but has some significant challenges. So within this truck, the idea is to build a truck that does exactly what your diesel truck does, but it just uses electricity as the energy. Yeah? There's a problem with that, because that means you've got to store the energy on the vehicle in batteries. Two problems, in fact. One, based on the current cost of batteries, the cost of the energy storage is as much as a diesel truck. Okay, so you've doubled the cost of that truck. The second problem is to get the right sort of range using the current battery technology, then the weight of that energy storage is going to be 25 to 60% of the payload. That means you're going to have to send out more or less twice as many trucks. Okay, so it's not clear what the solution is, but at least people are moving in the right direction. Now, this is my bit about promoting the work that the Centre for Sustainable Road Freight has done. And there's people in the room that deserve to take more credit than me. We started the ball rolling by writing a report for the Committee on Climate Change, and people like Anna Keys and Pratyush were involved in that. That report gave the evidence base that led to the DFT developing and issuing the most recent strategy document, which is the Road to Zero, which basically is a strategy to get zero emissions freight transport, okay, by 2050. And we also did a series of reports for BEIS, and they were looking at CO2 reduction and the alignment of CO2 reduction strategies with air quality improvement strategies, because that's another piece. And happily, those two objectives overlap. So we've done a lot of work on this for the first 5 years, and that allowed us to confirm that if you are looking to reduce CO2 emissions from road freight, the best you can hope for with the current technology is about 50%. Okay? It's not going to get to the 80%. Now, at this point, I'm just going to flick back to one slide. Not that one, although I like it. There, okay. When we talk about transport being 27% of CO2 emissions, road freight is about a quarter of that. So it's 5 or 6%. And that may not seem like a lot. And it isn't. Okay? But that 5% is what gets you to your 80%. It's the last piece in the jigsaw. Without it, you don't complete the jigsaw. Without it, you don't stop irreversible climate change. And irreversible climate change occurs because the sun's rays melt the ice with climate change. Okay? As you melt more ice, you lose the reflective surface of the planet, so you more energy is absorbed by the planet, and that melts more ice. Okay? And that is a vicious circle. It just keeps going. So if you don't get that 5%, you end up in the problem space, of these vicious circles, feedback loops that are unpredictable and nobody knows where they stop. And that's kind of the argument about climate change in a nutshell. So that's the environmental picture and why logistics is important. And what I'm trying to do here is paint a picture of the conditions that I believe will mean we have to reinvent the logistics wheel, as it were. Okay? And the environment is one of those reasons. The other reason is a video I'm going to show now. I'm going to stay quiet in this video. But this is about an approach to using big data to change the way you do logistics. It's a bit of a quirky, sort of funny schoolboy type of video, but it makes a break from listening to me. Oops. Okay, sounds a bit unrealistic, doesn't it? Okay, but Amazon are actually doing it. Okay, they're using big data to predict what you were going to order. And I didn't believe this was happening until a colleague of mine went on an Amazon website and hovered over a particular book. He didn't order it, he just hovered the mouse over it. And it arrived. Okay? Now he thought it was a mistake, so he got back to Amazon and he said, look, you've sent me this book, it's obviously a mistake, I don't want it, blah, blah, blah. Amazon said to him, keep the book. All right? And what that shows you is that Amazon have started to use big data to create value out of logistics that wasn't there before. Because they're not seeing that as a logistics cost anymore, they're seeing it as customized marketing to you. Okay? The big data analytics that went on in the background told Amazon that this guy, a colleague at Cambridge University, was interested in that sort of book. It then calculated how much that book was worth to Amazon. And it then did another calculation that said, actually, we're willing to spend that to show this guy that we know what he likes and give him that book. Okay? So it's happening. Big data allows you to ship products before you've got an order for it. Now, you're not going to do it with every product, are you? You're not going to do it with Ferraris, clearly. That would be great. We'd all be hovering over Ferraris. But it is a possibility that we start to entertain shipping products before you've actually received an order. Okay. So part of the thing that makes this big data possible is the amount of things that are now connected. So things talking to things. And two points I want to make about this slide. The first is that the growth in things connected to the internet is exponential. Okay? It's growing faster every year. The second thing is to say there's 25 billion by 2020. That's roughly 4 things for every person on the planet connected to the internet. And all of that data is being captured, describes your movements, your health, the things that you're interested in purchasing. And that's what allows Amazon to create new value streams from logistics. Amazon aren't really interested in doing logistics because they want to move stuff from A to B. They want to capture the value created from the data associated with that. So the other point I want to make is about how operating costs for trucks may change. Okay, these are sort of average figures, but essentially a huge part of the cost of running a truck is the driver. Right? Then there's a little bit of fuel, and then there's all the other stuff that you have to do, maintenance, insurance, and so on and so forth. If you change to an electric truck, you reduce the fuel costs. Yeah, you still need the driver. and you've probably still got roughly the same amount of overheads. They may increase a little bit. That's kind of the picture with an electric truck. Electric trucks cost twice as much as your diesel truck. So, question, are you going to buy electric trucks based on that? And the answer probably is no. Yeah? However, if you take the driver out and you have an electric truck that is an autonomous vehicle, the costs reduce down to about 30% of your diesel truck. And then you're starting to get into an economic profile that would allow you to invest in the electric vehicles. Now, if investing in electric vehicles is a desirable outcome because of the environmental pressure, then the best way to do it is make them autonomous. That also, by the way, addresses the emerging driver shortage problem that we've got everywhere in the world, which is the demographics are changing, which means that we don't have enough drivers to drive the trucks. Okay? So it's kind of interesting. It's not about electric vehicles anymore. It's about autonomous electric vehicles, because that's the only way the economics may work. So I also want to say a little bit about autonomous vehicles and urban deliveries. Okay, so urban deliveries are a particular problem now, or a particular challenge. The urban deliveries are where we are delivering parcels and groceries to people's houses. Yeah? Now, if you talk to most supermarkets, they will tell you that their grocery deliveries to people's houses, they lose money on. Okay? If you talk to parcel delivery companies, they will tell you the biggest problem is that they have to make the trip 2 or 3 times because the people they're delivering to aren't where they should be. You know, they're not there to receive the parcel, so unattended delivery problems. So, got 2 videos here. The one on the left is going to take you through a story which is about a solution that exists now, that is being trialled in a number of cities across the world, which is an autonomous home delivery vehicle. And the video on the right, as you're looking at it, sorry, I realise I'm facing a different way to you. So the video on the right with the snail trails, each colour on that video represents a parcel courier. Okay, and this is one day in one postcode in London. Okay, so on the left, you see you've got an autonomous vehicle. It's not a vehicle we would recognise as a truck or a van even. It's much smaller. Okay, it's also much slower. It could be refrigerated. It is secure. You open it with a pin. And it is being trialled. The video on the right tells you that parcel carriers multiple parcel carriers visit the same street on the same day. Which begs the question, how could that be made more efficient? Okay, so we've got autonomous connected vehicles, which I would start to suggest is reinventing the wheel. There is no driver. They are much smaller, and they are designed to deliver specific packages to people's houses. And we've also got the problem where we've got lots of parcel courier companies going to the same street on the same day. Okay, so we've got this sort of perfect storm developing. We've got technology which we can't stop, which is autonomous vehicles. We've got connectivity with 4 times as many things being connected and passing data to the internet as we have people. We've got what I call the environmental imperative, which sits right at the centre of all this. We cannot ignore the environmental imperative. It will not go away, and the consequences could be disastrous. We've got data and big data generated through this connectivity, and we've got the developing art or science of artificial intelligence. And that artificial intelligence allows us to organise things that are connected in a way that allows the things to make decisions. So in other words, we don't have these centralized control systems anymore sitting over the world where information is passed up to them, they make some sort of decision and they organize the logistics out of that. What we've got is things down at the bottom of that system that are talking to each other and organizing based on what they understand other things are doing. It's a very dynamic and a very devolved system. So this perfect storm describes a complex system. Okay, so here's the science bit. Okay, next few slides are about what really makes me tick as an academic. So it describes a complex system, and in a complex system you've got a multitude of dependencies, things depending on other things. You've got autonomous action, so things within this system making their own decisions about what they understand the world to be. And those decisions constantly create a new world or a new environment to which all the things in it then have to react. And it's very hard to articulate this and sort of describe what it is. But the best way of doing it is to say, if you pulled one of these loose ends in this, you would have no idea of its consequences. You couldn't predict pulling this one will change the shape of that ball of connected things to something else. You couldn't predict what it would be. Yeah? That means it's non-linear, it's non-deterministic. Yeah? The equations that we've used for optimizing these systems for decades don't work in this system because it's unpredictable. So, what does it look like when we start not just thinking about pulling the single piece of string that changes the shape of that ball of multiple pieces of string? What does it start to look like when it's dynamic? Okay? So this is what we call a complex adaptive system. Now, a complex adaptive system is one that has lots of agents in it. So each one of these we would call an agent. Yeah? Each one of those is autonomous. It makes its own decisions. It's not controlled. Okay? And every time one of these makes a decision, it results in a change to the environment. So the decisions of the many come together to co-evolve into a new system, to which everything in that system has to react. Okay? So I'm going to play this now. It's obviously a street scene, and there's sort of a junction here. Yeah? Now watch it carefully, because there are no collisions. There is no control, yet there is no collision. That's the first thing you observe. And there's no collision because there's rules. Each one of these has a rule that it follows. If it's bigger than me, avoid it. That's generally a good idea. If it's bigger than me and moving fast, make sure you doubly avoid it, if that's possible. Yeah? If it's slower than me and smaller than me, I can probably carry on. And everything understands these rules, and this is what we call self-organization. Yeah? There's no control. It's everything acting autonomously. You could build a simulation of this, which is a computer simulation, or you could actually imagine these as those autonomous vehicles that we were looking at before. Periodically, the flow changes. Everything stops and they work something out. Okay? That's what we call punctuated equilibrium. In other words, it works as a system in a certain way for quite a long time, and then it stops and it changes. Yeah? Rather dramatically, we also call those extinction events. Okay. And in a complex adaptive systems, one of the things we know is there will always be punctuated equilibrium or extinction events. Those are the moments when we have to stop building on the endeavours of others and we have to reinvent a new way of doing things. Yeah? What we know from the science bit is that the conditions that create punctuated equilibrium exist right now for logistics. There's a lot of change in technology, in data, in the environmental reasons to motivate you to change. Okay? So these things exist. I would argue that it's more or less inevitable, as a consequence of that, that we are looking into the face of radical change. And if I'm right, then we're moving away from a position where the future possibilities are normally defined by our recent past, and we have no model in the rearview mirror of what the future will look like. We're going to have to reinvent it based on the new conditions. Key to doing that in the best possible way is understanding complexity. Okay? So what we can create, and there are people in the room working on these models now, what we can create is a model that creates a virtual world of the real world at large scale. So when Richard talks about the work I did at Cranfield, that was to develop a simulation that had in it 400,000 vehicles, which is the entire UK heavy goods vehicle fleet. And it built a simulation. All of those were autonomous. They were satisfying orders, they were self-organising, and they were producing journeys. Now, we don't just build one simulation because that isn't very helpful. Yeah? That would just tell us how the world exists now. What we need to do in these moments of punctuated equilibrium or extinction is we need to entertain the possibility that there are many thousands of potential futures. And what we can do with the computer simulations is find the characteristics that appear in most of those worlds. If we can find those characteristics, we can build strategies to work with them. Now, at a national level, that means you build robust policy for logistics. At a company level, it means that you pick the right strategy. So, up until now, the logistics system has been defined by the horse's bottom. I would start to argue that in the future, it's going to be defined by bits and bytes, in other words, data. One last thing before I finish. This is another video. It's quite an entertaining one because part of what I've been saying is to try and create new value from logistics. You know, the new business models that will work will not be about charging X pounds to move a pallet from A to B. It will be about that plus some new value that we can create from it. So this is, well, I'll let it play and then I'll talk about it. So that is what we would call crowdsourced logistics in broader terms. Okay? So in other words, we're using people's personal transport to move goods around. Okay? What's interesting though is that this has been positioned not just as a logistics service, it's been positioned as a dating service. Okay? So you can pick who you're going to deliver parcels to. Yeah. Now, you might find that a little bit spooky and a little bit scary, and to be honest, I do. But it shows that there is alternative value streams to be developed out of logistics. And radical change will only happen when those different value streams are realised. Yeah? The last thing I want to say, really, is that you can look in history at in sectors that have undergone radical change recently. So book selling is one, and music is another. Okay. What you can say about those sectors is the change never came from within the sector. Yeah? And that's something we call the competency trap. Okay? The people in the sector, as it matures, get so good at doing what they do, they don't believe anybody could do it better. And that's not unreasonable to believe that. You get your efficiency as best you can for the processes that you have. But then when somebody comes along like Amazon and starts selling books on the internet, they change the value proposition. Yeah? They weren't booksellers, they're an IT company. The change came from without. If you look at iTunes and electronic music, it's not the people who used to press the records that changed the industry, it's the people from outside. And quite often I get asked the question, who's going to change logistics? Well, if I'm right and it's about bits and bytes, then it's going to be people like Amazon, Google, Facebook, the people who know how to get value out of data. Top of that list would be Amazon at the moment. But thank you for listening, and if there's any questions, please ask them.